Hi, so this is addressing Chapter 9, Worksheet 1, and we're looking at questions 6, 7, 13, 17, and 21. There's nothing outrageously sneaky about any of these problems in particular. What's probably tripping you up is remembering some of these factoring techniques that we used from previous chapters. So remember, if we look at the quadratics here in number 6, notice that each one of these, the leading coefficient isn't 1. So to factor these, what we have to do when we look for our two numbers is we have to look at A times C. So I want two numbers that multiply to give me 5 times -8. And then also add to give us 18. So I should be able to see that pretty clearly as 20 and -2. So what I'm going to do then is I'm going to replace the 18x there with 20x plus a -2x. And then I'm going to make my two groups. From the first group, there's a greatest common factor of 5x, leaving me with x plus 4. From the second group, there's a greatest common factor of -2, leaving me with x plus 4. And then if I look at this in totality, there's a greatest common factor of x plus 4. And when I factor that off, it leaves me with just 5x minus 2. And now I'll do the same thing for the denominator. So I want two things that multiply to give me 10 times -2, or -20, and then add to give me -1. So again, hopefully it's easy to see that that's going to be -5 and +4. So I'm going to have 10x squared minus 5x plus 4x minus 2. Make two groups. From the first group, I can take a greatest common factor of 5x, leave me with x minus 1. And from the second group, I can take a greatest common factor of 2, leaving me again with 2x minus 1. If I look at the whole thing, there's a greatest common factor of 2x minus 1, leaving me with 5x plus 2. So for number 6, the numerator factors x plus 4 times 5x minus 2, and the denominator has 2x minus 1 times 5x plus 2. And if I look there, it does not appear that anything cancels, which makes me wonder if I made a little mistake somewhere along the ways here. But it doesn't seem like it. So I think that that one just is prime and there's no more reducing that can happen there. Okay, so let's look at number 7 now. So again, there's nothing to do there. We factored it and we checked, but there's no reducing to do. So for number 7, the denominator should be easy to handle there. That's just going to factor to x minus 3 times x minus 5. Two things that multiply to give me +15 and add to give me -8. So nothing tricky going on there. Now, the numerator, though, has 4 terms on it. So to handle that, I'm going to just use that grouping technique that we used in the previous problem. So I already have 4 terms, so it's basically just kind of like this step. So I'm going to make my two groups. Here I can take out a greatest common factor of x squared. From this one, I can take out a greatest common factor of -3. And I notice now I have an x minus 5 in common to both. When I factor that out, I have an x squared minus 3. So if I take this over this, I have x minus 5 times x squared minus 3 over x minus 3 times x minus 5. And those two reduce out And I'm left with just x squared minus 3 over x minus 3. We also were curious about number 13. So x plus 5 is prime. There's nothing to do there. If I look at x squared plus x plus 1, again, that's prime also. There's no factoring to do there because there's not two integers that multiply to give us 1 and also add to give us 1. But if I look at the denominator, x cubed minus 1, I recognize that as a difference of 2 cubes. So the difference of 2 cubes factoring pattern that you may or may not have remembered was this. So in this case, our a is just x, because the cube root of x cubed is just x. And our b is just 1, because the cube root of negative 1 is just 1. So what's going to happen here is we're going to have our x plus 5. And then our denominator is going to be x minus 1 times x squared plus 1 times x plus 1 squared. So just that. And then we're going to be multiplying it by this. And those will reduce, leaving me with x plus 5 over x minus 1. 17, I'm suspecting the issue is trying to factor this part of it, which again, reminding back to what we did on 6 and 7, or I'm sorry, just 6. Since the leading coefficient isn't 1, we need to find two things that multiply to give me a times c, which is 12, and add to give me b, which is 13. Again, easy to see that that's going to be 1 and 12. So I have 3x squared plus 1x plus 12x plus 4. Make my two groups. From the first group I can take out an x, leaving me with 3x plus 1. From the second group I can take out a 4, leaving with 3x plus 1. I notice I have 3x plus 1 is common to both. So when I factor that out, I have x plus 4. And then x squared minus 4 is x minus 2 times x plus 2. And then since it's division, I'll make my reciprocal. So the x plus 2 that was in the denominator is now in the numerator, and I've changed this to a multiplication symbol. And in the 4x plus 16, I can take out a greatest common factor of 4. And I'm just going to look to reduce, so I can reduce those pieces, leaving me with just 3x minus 1 over 4 times x minus 2. And that's all I can do there. Last up is 21. Again, probably the issue here is factoring 2x squared plus 3x minus 5. If you couldn't remember how to do that for the other ones, I'm sure it's probably been the same issue throughout. So again, two numbers that multiply to give me first times last, which is negative 10. And add to give me that middle, which is 3. So those two numbers are 5 and negative 2. So I have 2x squared plus 5x plus negative 2x minus 5. Make my two groups. From the first group I can take out an x, leave me with 2x plus 5. From the second group I can take out a negative 1, leaving me with 2x plus 5. And then I have a 2x plus 5 in both, so that leaves me with an x minus 1. I still have over 6x. And then times, so I'm going to make a reciprocal for this piece. So the 1 is going to go in the numerator. And then if I factor 2x squared plus 5, I can take out an x. And that leaves me with 2x plus 5. So there, those will cancel, leaving me with x minus 1 over 6x squared. And that's it. Hope that helped.